Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on September 23, 2025, which was about 3 days ago. The hook is simple. This paper unifies language, images, and 2D goal poses into one navigation policy and reports 100% success on the evaluated image tasks. The paper is titled OmniVLA, an Omni-Modal Vision Language Action Model for Robot Navigation. And as we will see later, the implications for generalist robot control are quite significant. Beyond images, the unified policy beats pose specialists by about 9% and even composes goals, reaching 80% success on long routes. Alright, the introduction set the stage with Omni-Modal goals and headline results. Figure 1 presents the overall recipe, which starts with a diverse dataset over 9,500 hours from 10 platforms. The center pipeline shows OpenVLA 7b, taking tokens from current and goal images, a projected goal pose, and a tokenized language prompt, then producing n-planned actions. The right panels illustrate deployment across different robots and goal types, so conditioning stays flexible in practice. So, the previous figure outlined the end-to-end pipeline. Figure 2 shows the core architecture. A Llama 2.7b backbone takes tokens from current and goal images, a projected 2D goal pose, and a tokenized language prompt, then predicts n-step actions through an action head. The image encoders use SIG-LIP with Dino v2, while a small projector turns poses into tokens. Random attention masks hide some modality tokens during training, which forces the policy to work with any subset of inputs and stay robust. So while Figure 2 detailed the token routing and masking, Table 1 summarizes the training mixture that feeds it. The table lists 4 major sources spanning about 9,500 hours across 10 platforms, with action sampling at 3 Hz for most sets and 1 Hz for highway driving. Languages, 2D poses, egocentric images, and satellite views appear in different combinations, which forces broad coverage. Labels range from raw human actions to synthetic re-annotations using NOMA-D and MBRA. So, while Table I summarized the training mixture, Table 2 reports single-modality results. The unified policy leads across the board. Language success rate reaches 0.73 with behavior at 0.65, and simple cases hit 1.00, which signals strong instruction following. For 2D poses, success is 0.95, with progress 0.98, clearly ahead of MBRA pose and NOMA-D. For goal images, success and progress both read 1.00 because the shared training learns consistent visual and geometric cues. Okay. Table 3 tests whether training on multiple modalities helps OmniVLA edge. The Omni-Modal row, trained on G-North-M, Lane North, Frodobots, and BDD, reaches 0.60 for language, 0.91 for 2D pose, 1.00 for ego image, and 0.57 for satellite image. Single-modality rows lag, with language at 0.43, pose at 0.86, ego image at 1.00, and satellite image at 0.19. The pattern shows broader training boosts generalization across test modalities. So while Table 3 showed gains from multimodal training, Table 4 tests true composition, reaching a 2D pose where, while following language how, the OmniVLA row posts 0.80 success rate, 0.86 progress, and 0.60 behavior, which beats pose specialists like MBRA pose at 0.70 success and 0.80 progress. Smaller VLA baselines collapse on behavior, and OmniVLA edge trails, so capacity and omni-modal conditioning clearly matter. Alright, 2 takeaways stand out. A single policy handles language, images, and 2D poses with strong results, and randomized modality fusion teaches robust behavior that even composes goals over long routes. The broader implication is a practical path to generalist robot navigation that adapts to new sensors and tasks with light fine-tuning. Thanks for listening. I am Alex.